All right, I love this topic because graphing really opens up so much in science and in our daily lives. So with graphing, we're going to be on page 3 and 4, loose leaf paper if you run out of room. Looking at these three objectives: read a table or graph and interpret data. Need to be able to create a graph or table, again, if you're given that information, and then interpolate or extrapolate information based on a graph or table. Now, those two words, interpolate or extrapolate, those are things you already do. They're just new words for something that you already do. So, from there, we're going to pick up with creating a graph. Before we can understand how to create a graph, first we need to know independent versus dependent variables. Again, this should be something you've seen previously. I'm just doing a quick review for you. So independent variable is going to be whatever is the thing that changes on its own. Okay, that changes. That's the primary thing that's changing. Okay, so in this case, time in hours. Okay, so you've got time in hours is the thing that is going to change and then cause a change in the other thing. Okay, and that causing the change in the other variable is what helps us to know what the dependent variable is, because it's dependent on the independent variable, right? So in this case, when I change my time, that changes the distance that I've traveled. Okay, so my dependent variable is the one that is changing because of the other variable. Okay, then if we're looking at this one in particular, what do you notice about this data? What do you notice in this chart here? Well, one thing that you could notice here is you could notice that my time is going up by 1 hour each slot. Okay. You could also notice that each hour that I'm going up by 30 miles. Okay. So to go from 30 miles to 60 miles, at hour 2, I went up 30 miles. So I went an extra 30 miles. When I went from the 2 hours to 3 hours, I went up another 30 miles. Then again 4 hours, and I've gone up another 30 miles. So one thing that we can do with this is we can fill in information, right? So we're missing that 5 hour mark. Okay. So if we're trying to figure out what 5 hours would be, I'll put that over here just for consistency. If I was trying to figure out what 5 hours would be, that would be another 30 miles. So that's 150 miles here. And say I felt like this data didn't go quite as far as I wanted it to, and I wanted to see what my 7 hour would be. Well, again, based on the pattern here, I can kind of figure that out. So another 30 miles. If I went another hour, I'd get another 30 miles, and that would be 210 miles. Okay, that's where I was saying you already know how to do this stuff, because then you can make a graph of this. You've got my independent variable, that's what my time was, my independent variable, the one that changes on its own, or changes first, that's going to be on my x-axis. So independent is this x-axis on the bottom here. Okay, so independent is that bottom line. If you want to look at my dependent variable, that's going to be on my y-axis. And my x and y axis are going to be, again, x-axis independent variable and y-axis dependent variable. Then you've got, we figured out that 5 hours was going to be 150 miles. That's where you see right here, there's a data point that's not there. Okay, And if you fill in data on the inside, that's what you call interpolation. So you interpolate that data. Okay? When we figured out the data that was going to be next on the outside of that, that was extrapolation. So you extrapolated that. Okay? So that's the difference between interpolate and extrapolate. Again, that's where I was saying you already do that. It's just a matter of relating that back to those vocabularies. So we've got, what do you notice about this line, right? We've got, just like we were saying, it increases by 30 each hour. And another thing that you can notice is that it goes through the origin, the 0, 0, right? Because if I have spent 0 hours traveling, I'll have gone 0 miles. So could you draw a best fit line? That means that a line that fits this data well? Well, absolutely. It goes right through those data points. You show the shape of that graph of that line. You show the dependent versus the independent variables, and interpolated that 5-hour mark that was in the middle of the data, extrapolate the 7-hour mark outside of the data. Okay. So using this, what could we infer? So if I traveled 16 hours, how far would I go? Well, you can do this kind of conceptually. I know that I'm going 30 miles an hour, and I know that I'm saying I've gone 16 hours. So if I multiply those, then that would give me my answer here. And so that would give me 480 miles I would have traveled, right? So that'd be way off the graph, but I can use this line as information to figure that out, extrapolate that, if you will. And then if I wanted to go 1,200 miles, how long would it take me? So this is where I've got 1,200 miles, and if I divide that by my 30 miles per hour, then that would give me my 40 hours. It would take me 40 hours to go that 1,200 miles. Okay, but you can also use some math skills to come up with this. So what you should notice about this line is that it follows a very specific trend here. Okay, and that's helpful because we can actually create an equation for this line. So we've got using the formula y equals mx plus b. Again, this should be information you've already seen before. We've got m is the slope and b is the y-intercept. So where it actually hits that y-axis here. So notice it's going to hit that at the origin because we figured out that it went through 0, 0. So b is going to be 0. And we already know that, I don't know how you were taught this, but the way that I was taught this is go like that. This was the rise over the run, and that'll tell you. So here I've got a rise of 30 miles and a run of 1 hour. So 30 divided by 1 is going to give me 30. So my equation for my line, I'm going to do that in black so it's distinct, is y equals 30x plus 0. But of course you could leave that 0 off and that'd be totally fine. Okay. So then let's figure out some others. Go ahead and see if you can pause this video and try to figure out the equation for this line. Okay, we've got, again, that formula is y equals mx plus b. I like to personally figure out b first. That just helps me. So I'm looking on the y-axis here, and it looks like it crosses here at 1. So when y is 1, that's my y-intercept. So this is going to be 1, and then I've got to figure out my line. Again, do this right here. Rise of from 1 to 2 is a rise of 1, and a run from 0 to 1 is 1. So that's y equals 1 over 1 x plus 1, which is just y equals 1 over 1 is 1, so plus equals x plus 1 would be my equation for this line. Next, try this one. We've got y equals mx plus b, and x, or b is right there, which is 2, 4, 6. So that's going to be b equals 7, positive 7. And find my slope. Go over 2 and up 2. We've got a rise of 2, a run of 2. So m is 2 over 2, which is the same thing as 1. So y equals x, or 1x if you want to show that, plus 7. Okay? Then I'm going to skip this one. Go ahead and see if you can figure this one out. Looks like that is pretty blurry, so let me 0.5, 1, 1.5, and goes up by 0.5 each time. This is 2, 4, and 6, and goes up by 2 each time. Okay, so let's try this one out together. We've got a little bit different here. The line slopes downward, so that's going to change some things a little bit. So we've got b equals, we're looking right here, so b equals 3, and then we've got over 2, then down, so that's a run of 2, and a rise, but it's going down, so that's actually going to be a negative. It goes down from 3 to 2, so negative 1. So we've got a slope of my rise is negative 1 over my run is 2. So then my answer is going to be y equals negative 1/2 x plus 3. Okay? So with that, we're going to try to get the equation for both of these lines here. We're actually going to skip these two. So using that, we can kind of use our reasoning here to figure out more complex graphs like this. Really all you're having to do here is look at this and pull the information off of the graph. That's something that is very common, like on the ACT science section, like so often. Is it just they give you the information there, and it's your job just to be able to Sorry, my headset shut off. So we've got then independent and dependent variables. Independent is my temperature in degrees Celsius here. Dependent is my grams of solute per 100 grams of H2O. So if we're looking for KNO3 line at 50 degrees Celsius, before we jump into that, how we're thinking about this, let's look at the Ki line right here. Okay. So if we are looking at 20 degrees Celsius, then what this line tells me, based on my dependent variable here, is that wherever this line is at that temperature, that's how many grams of solute per 100 grams of H2O I can dissolve. Okay, so in this case, at 20, that is 130 grams of whatever this Ki is. Okay, again, just like on the ACT, you don't actually have to know what that is. We'll dive into that later on in the semester, but the important thing is to be able to pull that information off of the table. Okay, so 130 grams of Ki can dissolve in 100 grams of water. So then if we're looking back at the question at hand, KNO3's line is right here. And we want to look at 50 degrees Celsius, so that's there. So then I'm looking at that spot on the graph here. At 50 degrees Celsius, I can dissolve 80 grams if I have 100 grams of water. Okay. So if you're thinking, like, what if I have twice as much water though, right? Well, pretty logically, you can have twice as much of the KNO3. So if I double the grams, if I've got 200 grams of water, then I double how much salt I could have. So instead I could have 160 grams of KNO3. If I tripled the grams of water, then I'd triple how many grams of KNO3 I could have. So that would be 240 grams. If I halved the grams, if instead of 100 grams I had 50 grams, then I'd be able to have 40 grams of KNO3. Okay? Again, the point isn't necessarily to be able to know what the KNO3 is or anything like that. The point is to be able to use your knowledge of graphs and charts to be able to pick apart what a graph is saying. Okay? And that's really the big thing that is going to be super helpful in chemistry as well as when you take the ACT science section. So in summary, be able to create a graph from a table, identify independent, dependent variables, be able to interpolate data, extrapolate data, create linear equations to represent graphs. That's the y equals mx plus b, and then interpret data on a graph and develop conclusions based on the interpretation. Okay, so that's what you need to be able to do. Go ahead and tackle that worksheet and come to class with whatever questions that you've got. Thank you guys so much. You guys are awesome.